we're going to talk about angles, and specifically different pairs of angles, their names, and their relationships. Now, this is going to be a big issue for a lot of people. When we talk about angle pairs, there are two things we're always going to be discussing. One is the name of the angle pair. The other is the relationship the angle pair has. They are different. The name is going to always be something like, we're going to have all these different names over the next few days. Corresponding, supplementary, complementary, alternate exterior. We're going to get all these different names. The relationship is always going to be one of two things. The angles are either going to be congruent or supplementary. Supplementary we haven't talked about, but you'll learn what that name means in just a second. All right? But it's going to be one of those two things. That's always going to be the relationship. So always keep in mind there are two facts we need to know about each angle pair that we get. One is the name. Second is the relationship. So there are always two things we're looking at. And sometimes we'll just learn the names first, and then we'll learn the relationship second. Sometimes we'll learn them together. So let's talk about this. First off, adjacent angles. Adjacent angles have the three following properties. They share one side, they have the same vertex, and they do not overlap each other. No common interior points. So, that's what it means to be adjacent. Adjacent, and when you think of the word adjacent, it means just next to, right? I mean, if my house is adjacent to the park, it means the park's right next door. So adjacent has a specific meaning, means next to. Two angles next to each other. It's always a pair. So like, for example, these angles, ACB and BCD. If I call them angle 1 and angle 2. Those two angles are adjacent. They have the same vertex. They share one side, or ACB, and they don't overlap each other. Whereas ACB and ACD, okay, so this whole thing versus just this small thing, those would not be an adjacent pair. And they wouldn't be an adjacent pair because, well, they do share a vertex, they do share one side, but they overlap. So not adjacent. Have to have all three properties to be adjacent. ACB and EDF would not be adjacent. They don't share a side, they don't overlap, they don't have the same vertex, not even close. But what would be an angle that would be adjacent to EDF? EDC would be adjacent, wouldn't it? These two would be adjacent. So that's what adjacent means. Now, adjacent pairs don't have any particular relationship other than their proximity to each other. They aren't congruent. They aren't supplementary. They don't necessarily add up to anything special at all. They're just adjacent. Got the idea of adjacent? That's an important idea. Complementary angles and supplementary angles. Very simple. Two angles, and by the way, these are pairs of angles, not triplets or quads or anything like that. Pairs, just two. Complementary angles add up to 90. Supplementary add up to 180. The way to keep that straight is its alphabetical order. Complementary is a smaller total, supplementary is a larger total. One that comes first is smaller, one comes second is larger. So they always add up to 90 or 180. So if I have an angle of 50, what would the measure of the complement be? 40. How would the measure of the supplement? 130. How about 35? Complement would be 55. Supplement? 145. Have you noticed supplement's always 90 more than the complement? Yeah, because it has to be. Because it always has to be 90 more, doesn't it? Okay. 85. Complement would be? And 95. How about 100? What would the complement be? 80 would be the supplement. Okay, but can we have a negative 10 degree angle?
No.
Can you draw me a negative 10 degree angle? Not till we get to trig or precalculus can we start dealing with negative angles. So we are not going to deal with negative angles, so we would say there is none. All right, there is no complement because they're already greater than 90 by itself. Okay? What if it's x? What if my angle measure is x? How am I going to represent that from an algebra standpoint? The complement is always 90, no, minus x. Look at the pattern. It was 85, it was 90 minus 85. It was 35, it was 90 minus 55. See? What would the supplement then be?
180 minus x.
There we go. So, complement and supplement. Those are important types of angle pairs. Now, in order to be complementary or supplementary, they don't have to be adjacent. They don't have to be on the same plane. They don't have to be anywhere. They just add up to 90 or add up to 180, depending on which one we're dealing with. Okay? So that angle pair name has nothing to do with the proximity or location of the angles towards one another. It just has to do with their measurements. So if you have one on your desk that's 40, and over there's one on the board that's 50, they're complementary angles. Has nothing to do with location, only has to do with measurement. Linear pairs and vertical angles have everything to do with location. Linear pair happens when I have two angles that together make a line, hence the name linear pair. Makes sense? It's a pair. How many angles in a pair?
Two.
Two in a pair, right? It's not three of a kind. It's two. And they make up a line, so it's a linear pair. They add up to 180, obviously. They're supplementary. And they're adjacent. Very important. The linear pair, they are adjacent, which is a vocab we just learned, and supplementary. If we put the two together, that's how we get a linear pair.
Okay.
Question?
Why do we, what is supplementary and complementary used for, like?
Just as descriptions.
Description? Okay.
Yeah. It's just a way of saying they add up to 90 or add up to 180.
All right.
It's a way of avoiding the whole phrase.
Okay. I was
Yeah.
like, what?
Yep.
They're not in linear. Okay. All right. I'm good.
So, again, linear pairs, they make up a line. Now here, in this picture, I have several linear pairs. 4 and 5 are a linear pair. 5 and 6 are a linear pair. 6 and 3, and 3 and 4. They're all sets of linear pairs there, aren't they? But even more so, let's look at what else we have. We also have these angles that are across from each other that aren't linear pairs. Guess what we call those? And they're not quite adjacent. Are they adjacent? Let's look at them for a second. They share the same vertex, but do they share a side?
No.
They aren't adjacent, are they? Okay. We have a special word for them. Oops. Special word for them. They are called vertical angles. Now, vertical has nothing to do with up-down. 4 and 6 are a vertical pair. 5 and 3 are a vertical pair. They share a vertex. Vertical comes from the term vertex. They have the common vertex, and they're across from each other with linear pairs. But they are not supplementary or anything like that. They're just what we name the pair that's across from each other when this happens. Okay? Lots of vocab here. If you don't have these on flashcards, you're going to want these on sleeves. These are great flashcard things because you can so easily, just with your flashcard, okay, draw in on one side this, angle 1, angle 2, and on the back, right, supplementary and linear pair. Okay? It's so easy to do that. So you can look at the picture and identify it right away. This is what we want. This is a great place for your flashcards. Make sure you're getting these angle pairs in flashcards. Know their properties, be able to identify them on site. Okay? Some theorems about angles. And we are out of here today at the 4th hour, 22. So we got 7 minutes. I'm not going to go through the proof right now, but here's a theorem for you. Well, I may do it very quickly. All right angles are congruent. Shocking, isn't it?
Well, they have the same angles.
Okay. Why? Because they have the same measure, exactly. So a proof might look something like this. Angle A and angle B are right angles. Given. Measure of angle A is 90. Measure of angle B is 90. Why? Because that's a definition of a right angle. So if they both equal 90, that means the measure of angle A equals the measure of angle B. Substitution. Substitution property. Okay? And if they have the same measure, that means they're congruent. Definition of congruence. Okay, I'm not going to spend a lot of time explaining to it, but that is a logical argument. That is an actual proof of that theorem. We've done it with algebra. You aren't expected to do it yourself tonight, but I want you to start seeing this is how we make logical arguments in geometry. This is how we prove things. Start with some given information, use facts to build the fact that all right angles must be congruent. And again, fairly obvious. That one's pretty easy. The next one is a little bit trickier. Congruent supplements. If angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, then angle 1 and angle 3 must be... You'd think that, wouldn't you?
No, they're so...
They're what?
They're, complementary.
Oh,
Oh, no.
wrong C word, but getting in the right direction there. Congruent, yeah.
I said it.
Okay, and let's go back 2 slides. Okay, let's look at this. Angle 4 and angle 5 are supplementary, right?
Yes.
Angle 5 and angle 6 are supplementary, aren't they?
Yes.
That means angle 4 and angle 6 aren't going to be supplementary. Since they're both supplementary to this angle, they have to be congruent to each other. Just imagine for a second, to make it simple without a formal proof, let's say this angle was 110 degrees. This angle would have to be 70, right, because it has to add up to 180, and this angle would have to be 70. They have to be the same, don't they?
Yeah.
So vertical angles have to be
Congruent.
congruent. Okay? Because if this angle is x, then this angle has to be 180 minus x, making this angle x and this angle also 180 minus x. Every time. So linear pairs are supplementary, vertical angles are congruent, and two angles complementary to the same angle have to be congruent as well, or supplementary. Actually, we just did congruent supplements theorem. There's a similar one for congruent complements. Two angles complementary to the same angle are also congruent. So if angle 1 and angle 2 are complementary, 2 and 3 are complementary, 1 and 3 have to be congruent. There's a lot of stuff here. You got to be sure you are getting this down into note cards so you understand these rules of geometry and these names of these angle pairs. Postulate 12 we've already basically done. Vertical angles are congruent. We just decided that, didn't we? We figured that out without even needing to see the theorem on the board. And so vertical angles have to be congruent. Linear pairs have to be supplementary. Again, it's about a name and the relationship. So let's summarize quickly. Okay, I'm not going to look at the proof of that. I just want to... Well, here, let's just summarize. We'll get to the example if we can. Okay? We have supplementary pairs. That means add to 180. We have complementary. That means add to 90. We have linear pair, which is adjacent and supplementary. We have vertical pairs, which are congruent. Names and properties. That's what we're kind of about. How do we use it? Something like this. Algebra. Now, you say, oh goodness, I don't know how to set this up. Try to set the like variables together. I got y's here and y's here. I don't want to combine x's and y's if I don't have to. What kind of angle pair are the 5y minus 25 and the 4y? What's the name of that pair? Which one is it? Vertical pair. And they have to be congruent. The relationship is congruent. So 5y minus 25 has to equal 4y. Okay, which if you go minus 5y from each side, I get negative 25 equals negative y, so just change them both to positive y is 25. How about for x? What kind of angle pair do we have here?
Congruent.
Okay, that's the relationship. What's the name? Vertical is the name. Again, vertical, again, congruent. You're both right. So 3x minus 10 equals x plus 50. And again, we can solve this relatively quickly. So 2x equals 60, so x is 30. All right? So we can find these, so we can use this pretty quickly and easily. Yes? It was negative 1, and I just multiplied through by negative 1 both sides, or change sign both sides. The homework's on the web. I can put it up for you, but again, you need to be taking care of that